In this problem, we're looking at the population of a bird species over two islands. They captured and banded a group of 200 birds on island A and 250 birds on island B. The fact that these are different numbers is actually not particularly important and not a problem. So I wouldn't get caught up on the fact that one is 200 and one is 250. So these birds were captured, they put a little band on their leg, and then they released them back into the wild. They say here that sufficient time was allowed for them to return to their normal routine and location. Another thing that they could have said, if they were going to speak in a more statistical way, I guess you could say, is that they allowed enough time for the birds to become well mixed back into the population, so that these banded birds and all of the normal birds, the unbanded birds, all got mixed back together. So it's no longer, I guess if I had to draw a picture of all the banded birds that were captured here, and then all of the other birds floating around the island. Now, after some time, the banded birds are equally kind of spread out, maybe a few are clumped together, amongst all the other birds, and so forth. So they're well mixed into the population. Now, what we're going to do is we're going to start finding these birds again. It says they took a second collection after that period of time, allowing them to get mixed. And the second time through, on Island A, they captured 180 birds, but only 12 of them had leg bands. So let's say their new sample was right here, just these birds right here. You can see that some of the birds here are from the leg-banded group that they caught earlier, and then many of the birds are not. They're just from the general population. You might say, why would you do that? What is the purpose here? And we'll get to that in just a moment, but the idea is to be able to estimate the entire population with this. So first, we're going to go back and answer part A. Do the data from the subsequent samples indicate that there is a difference in the proportion of banded birds on these two islands? So if you captured so many birds and you want to see if the proportion of birds with leg bands is truly different on the two islands, based on your two samples here, what you're really comparing are two proportions. You have 12 out of 180 here, and you have 35 out of 220 here. So you have a proportion on island A and a proportion on island B. And you want to say if there is a difference in proportions. So it doesn't say that one's going to be greater than the other, which means that when you do your hypothesis testing, your null hypothesis is that the two proportions are equal, and your alternative hypothesis is that the two proportions are not equal. So P1 is not equal to P2. Now again, you would just use your calculator, a two proportion test, and since we have at least 5 successes and 5 failures in each of these, we're good to go. So pop this in your calculator. I would probably go x1, n1, x2, n2, and which one is group 1 and which one is group 2 is not particularly important in this example, but this is one way to do it. And then the statistical evidence to support your answer is going to be a p-value. And if your p-value is less than something such as 0.05, you would say, yes, I would say there is a difference in the proportions. And if it's greater than 0.05, you would say, well, there's not good evidence to support that. Part B, you can estimate the total number of birds by using the information of the number of birds in the initial sample. That's where that 200 comes into play that we took at the beginning, along with the proportion of banded birds in the second sample here. So use this information to estimate the total number of birds on island A. And so if we look at island A, we're going to totally ignore island B for a second. So just island A, the two orange numbers, we have in a banded sample, we have 12 out of 180. That's our fraction from the sample. But if we go back up, we know that there's actually 200 birds that have been banded on island A, and we only caught 12. So in the population, we have 200 birds with bands on their legs. So I'm going to actually write this over here on the side. We're going to do bands over total. So in the sample, we had 12 birds with bands out of 180 birds. In the entire population, we have 200 birds with bands, and we have no idea how many are in the total population. But that's what we actually want to find out. We want to estimate the total number of birds. So that's going to be right here. So since we have a proportion, let's go ahead and give this variable a decent name. Let's call it x instead of question mark. If we're going to solve a proportion, cross multiply, and so we would have 12x equal to 200 times 180. And if we're going to solve for x, we're going to divide both sides by 12. And so that's going to come out to 15 times 200, which is going to be about 3,000. So in this case, the total number of birds that we expect to find on the island is 3,000. And again, the way we worked this out was with a proportion. We knew that 12 birds were banded out of 180 that we captured. So 180 total birds, 12 of them had bands. And in the entire island, we know that there's 200 birds that have bands on their leg, and we don't know how many total. But if things are well mixed, we said that there was enough time here to allow things to become well mixed, we would expect this proportion to follow the way we expect it to here. Last part, the analyses in A and B assume that the samples captured in both the initial and subsequent samples can be regarded as random samples of the population that live on each of the islands. This is the assumption that is typically made by wildlife researchers in real life. That's what they actually do. They make that assumption that it's a random sample. There's a few concerns that you might come up with, though. If you think about birds being captured, well, perhaps it's the slow birds that always get captured, for example. If you're a not very fast bird, you're likely to get captured in the first sample and get banded. You're likely to get captured in the second sample, so that's going to cause your estimate to be a little bit off. You could also talk about the timing. If you do it too quickly, if you do your second sample too soon after the first sample, perhaps they're not very well mixed and all the banded birds are clumped together. They're not mixed up like we have in this diagram. And on the other hand, if you let it go too long, maybe a bunch of birds have gotten eaten or naturally died, or a bunch of new birds have been born and therefore changed the population. So again, you can't leave too much time because otherwise the whole population is going to change as birds are born and die off. You can't leave too little time, otherwise they don't get mixed. So estimating that perfect amount of time is going to be a little bit difficult because we have some competing factors. And there's a number of other things that you could find that relate to the imperfections with actual living creatures, given that they are all starting from the same point and dispersing across an island.